In this video, we'll practice using Venn diagrams to visualize sets and calculate the probabilities of randomly selecting an element in any of these sets. In this diagram, each circle represents a set. Let's call this set A and set B. This space in here represents the intersection of these sets. So we can notate this set A intersection B. This is the same as B intersection A. And this whole space, everything that's in both of these sets, is the union of these sets. So we symbolize this A union B, which is the same as B union A. Let's apply this to a real example. Let's say you have a bunch of friends who have pets. Most have dogs and cats, some have both, and some have hamsters and tarantulas. So let's call this set cat, and this set dog. So this becomes the intersection of sets cat and dog, and this becomes the union of sets cat and dog. The intersection is all friends who have both a cat and a dog, and the union is all friends who have either a cat or a dog. Now let's say you have 3 friends in the intersection and 8 friends in the union. Now out here, outside of the union, this is all friends who don't have either a cat or dog. This set is the complement of the union, anything that's not in either of these circles. Let's say you have 2 friends in this set. So that's everything out here. But we can also take the complement of set cat, so that'd be all of this, or the complement of set dog, which is everything outside of this circle. Let's say you have 6 friends with a dog, which means 3 who just have a dog and no cat. Well, if you have 8 friends in the union, that must mean there are 2 friends here who just have a cat and no dog, because 2 plus 3 plus 3 is 8. So the complement of set cat would be 3 plus 2, which is 5. Everything that's not in this circle. The complement of set dog would be 2 plus 2, which is 4. Hopefully you understand this concept of sets and the union and intersection and complements. Now we're going to practice calculating probabilities based on these numbers. If you randomly choose one of your friends, what's the probability that you'll choose a friend who has a dog? Pause the video and try to figure it out. So what's the probability that you randomly select a friend with a dog? This is 6, the number of friends with a dog, divided by the total number of friends that you have. Let's just call it probability of D for dog equals 6 divided by 10, which is 0.6. Okay, what's the probability of randomly selecting a friend who has both a dog and a cat? So we can notate this, the probability of C intersection D. Well, there are 3 in this intersection, so the probability is 3 divided by 10, which is about 0.33, or 33%. Finally, let's calculate a conditional probability. Let's say you have a dog, and it's your dog's birthday, so you invite all your friends with dogs to bring themselves and their dogs to your party. Your friends show up at your house in a random order. What's the probability that the first person who shows up also has a cat? We'll notate this probability that given this is a friend with a dog, that they also have a cat. What do you think? So this is the probability of selecting someone in set C, or set cat, given that they're also in set D. So you know everyone in this set D, is coming to the party. What's the probability that the first person to arrive is in this set right here, meaning that they also have a cat? Well, that would be the number of elements in this set divided by the total number of elements in this circle. So that's 3 divided by 6, which is 50%, or 0.5. This is the conditional probability. Try one more. If you randomly pick any friend, what's the probability that that friend does not have a cat? You might want to pause the video and try and figure it out. It'll help you if you think about it first before hearing me explain it. So the probability that you randomly select a friend that does not have a cat is the probability of the complement of this set C. So out of the total number of friends you have, which is 10, how many friends do not have a cat? 2 plus 3, which is 5. So this probability is also 50%. Great job!